Hello guys, it's Johnny time and welcome to another Solidity and smart contracts hacking and auditing tutorial. Today we're gonna solve the sixth exercise in Damn Vulnerable DEFI, which is the selfie. And in this video we'll do some kind of walkthrough to guide you through the process of solving the exercise, bypassing, finding all the vulnerabilities, planning the attack and implementing it yourself. So it's going to be super useful. So apparently putting the mic on is not enough. You actually need to know how to operate this thing, and as you probably know, hardware fails us all sometimes, and it failed me this time. It really failed me, and I hope that the next time it won't fail me and I will be able to provide for you videos with amazing sound quality. Thank you for the patience. And as you know, Damn Vulnerable DEFI is one of the best ways to practice smart contract hacking, and it's exercises and challenges that are based on real life events of DeFi hacks that happened in the past. A lot of flash loan manipulation, Oracle manipulation, yield farming, and much more. And this one is going to be about flash loans and governance manipulation, governance voting manipulation. So make sure to watch this video till the end to learn how to do flash loans and governance manipulation. And if you enjoyed the content, make sure to subscribe and click on the bell notification button, so when I post more videos about smart contract hacking, you can watch them as soon as possible. Now, without further ado, let's get started. So this is the selfie challenge, the sixth challenge in Damn Vulnerable DEFI. A new cool lending pool has launched. It's now offering flash loans of DVT tokens. So we have a flash loan. Wow, and it even includes a really fancy governance mechanism to control it. What could go wrong, right? You start with zero DVT tokens in balance, and the pool has 1.5 million. Your objective to take them all. So we have governance, we have flash loan, we have zero tokens, and our goals are to take them all. Now, the first thing we want to do is jump into the smart contracts code and the test files in order to analyze how the project, what is the logic that goes behind it. Jumping into the smart contracts code, this is the selfie pool.sol. This is the pool that provides the flash loan. You can see over here that is a smart contract non-reentrant. And there is this kind of modifier that checks that only the address of the governance sent the transaction. So it's probably going to be used later on, this modifier. Then there is the constructor who takes the token and the governance address, the smart contract of the governance and the token address. Then this is the flash loan function that allows you to borrow based on your borrow amount. It checks that the balance before is greater or equals than borrow amount, so it has enough DVT tokens to lend it to you. Then it transfers to the borrower the tokens, doing some kind of function call that basically this is the implementation of the borrower. This is basically the flash loan, and then at the end it checks that the balance after is greater or equals than the balance before. So this is traditional flash loan functionality. We won't go through it because we went through it in the previous exercises. You can check them out to understand how flash loan works. And then we have this kind of weird function that's called drain all funds, and it gets an address, a receiver, and it's external, but it has the modifier only governance, which means that only the address, which is the governance smart contract, can call this function. And as it looks like, as the name of it signs, it basically allows you to drain all the funds of the smart contract of the pool to this kind of receiver. So, which means that if we are able to call this function through the governance, we can somehow drain all the funds. So this is a hint of the solution, not the solution yet. Then we have the simple governance smart contract, which is the governance smart contract that the selfie pool gets upon constructor, upon initialization. And it has some kind of struct for governance. It gets the token, the Damn Vulnerable token, and there is the constructor, which is basically some type of counter that counts all the actions that the governance has executed, and also the token, the governance token. So based on the governance token votes, you can make proposals and probably execute them. So it has two main functions, queue action and execute action. The queue action makes sure that you have enough vote. If you don't have enough vote, you cannot propose any proposal for the queue. So this is interesting, and we can basically create proposals if you have enough votes. and the proposal will be to do something, and then we can execute the proposal. So the execute of proposal, also there is some kind of check that it can be executed. So first let's check what has enough votes. What it means to have enough votes. And has enough votes is basically checks that the balance that the user has that wanted to propose this proposal is greater than the half of the supplies of the old DVD tokens. So if you have more than half of the supply of the DVD tokens, you can propose any proposal, which is interesting. Now, can be executed is the other modifier, or the other check, not modifier, check, and it checks that there is some kind of delay. You can see it over here. So the delay here, what is the delay? Action delay in second, we can search for it, it's 2 days. So after you propose and you add transaction to the queue, you can execute it only after 2 days. So this is two things that we need to bear in mind. So this is basically the walk through the smart contracts, and this is the test file. All the setup is going through here. You can see that the total supply is 2 million tokens. In the pool there are 1.5 million tokens, which is great. It's more than half of the supply, right? We need more than half the supply. If we are somehow we're able to get access to this kind of tokens, we can maybe pass a proposal in the governance. Now, this is the setup of the contract, all the deployment of the contract, the sending the tokens, the checks. Here is our exploitation section where we have to write a JavaScript code that will implement the exploit, and eventually it checks that the attacker has all the tokens that is in pool, which is 1.5 million tokens, and the pool has 0, basically what was described in the instructions. So this is the exercise, this is the design of the system. And now if you want, you can pause the video and try to attack it yourself. If you want to see the solution, that's what we're gonna do right now. So the first thing before starting to write the code and exploit, we need to plan. Also, you need to get the attacker mindset and plan how we're gonna attack this kind of system that are built of two main smart contracts, which is the pool and the governance. The interesting functions are flash loan that let us do borrow. It has 1.5 million tokens, so we can borrow them, and then drain all funds can be called only by the governments, which is this kind of contract over here on the left. And this contract over here we can execute it, call the queue function and add proposals to the queue, but we need half of the supply of the tokens, which is 2 million. And then we have execute, and we need to wait 2 days. So now when you look at this kind of entire system, do you have in mind some kind of scenario how you're gonna attack this kind of system? Now let's try to plan the attack. So the first step is basically we want to borrow the tokens, we're using the flash loan, and then we have more than half of the supply. We can queue a transaction, add transaction to the queue, to the governance, okay? And that transaction will be obviously draining all the funds to our address, to the attacker. Then we're gonna pay back the flash loan so the transaction won't be reverted, and eventually after 2 days execute the proposal, the malicious proposal. So this is classic governance flash loan attacks that are going all over the place in DeFi these days, and this is great exercise to practice this kind of attack, so I love it. Now let's try to plan the attack. So first step, we want to execute the flash loan with all the pool balance. We want to basically take all the pool balance, even though we can take only 1.1 million token DVD, because we need more than the half supply of the total supply, which is 2 million. So 1 million plus 1 would be enough, but let's borrow all of it. Now, the second step would be, once we have more than half of the supply, you can queue a transaction, right, in the governance, because our address, the malicious contract that we will create, that will receive the funds from the flash loan, will have more than half of the supply. It will be able to add a transaction to the queue, to the governance. Now that we added a malicious transaction to the queue, we will pay back our loan, right? Because we want the transaction to succeed. After the flash loan, there is a check that makes sure that we pay back the funds. So we're gonna pay back to the pool, okay? Then we're gonna wait 2 days, okay? Because we have this kind of cooldown where we have to wait 2 days until we can execute the queue transaction. and then obviously execute a transaction, which doesn't require much. So this is the plan of the attack, and once we have the attack plan, it's much easier to implement it. And obviously we'll have to write a smart contract because the flash loan is gonna send us the tokens and execute a transaction that will trigger all the other action. So we have to create a smart contract, and let's jump into its creation.
Guys, I wanted to share with you something super exciting and new. I've created a complete practical smart contract hacking course accumulating 12 years of my cybersecurity and blockchain experience. Without exaggerating, this is your holy grail all-in-one course which will instantly help you kickstart your career in smart contract hacking and security, making you the most demanded professional with insanely high salaries. Get exposed to tons of knowledge by signing up in the description below.
So we're gonna create a new file, we'll call it selfie_attacker.sol, and we're gonna copy the Solidity version and all this kind of basic stuff, and we'll create contract selfie attacker. Now, since we have to interact with the governance and the pool and the token and all this kind of contracts, we have to implement their interfaces. We can also import the code, but in order to make it more efficient and gas optimized, we're gonna just basically write the interfaces. So we need basically all the functions except the execute, because we need to do it way today, so we cannot do it from the smart contract. So we need to implement all the interfaces for this kind of functions: flash loan, drain of funds. Actually, not drain of funds, only flash loan and queue. So let's write those interfaces. Over here, we have I pool, which will represent the pool smart contract. And for the pool, we will have the flash loan function. This is the interface, and the governance, we want I governance. This is the interface, and we need to implement the interface for queue action. Perfect, we have the interfaces, and let's start writing the code. So there is a constructor, and it will get some stuff, and it will do some stuff. And let's define some addresses first. So address, private, attacker. Then we need to define the pool, so it will do I pool, private, immutable, and we'll call it pool. Then we have I governance, private, immutable, governance. Okay. Now we need to also include the DVD tokens, the governance token that we're gonna send, transfer from here and there. So we need to write the interface as well. Interface I token. And for the I token, we need 3 functions interfaces. The snapshot, because we're gonna take the snapshot once we once we have half of the supply and we want to queue the transaction, we need to take a snapshot. It's ERC token with the governance extension, so it has this kind of snapshot function. Obviously, we'll need a transfer function, because once we get the funds after the flash loan, we need to transfer them back to the selfie pool's smart contract, and balance off to check how much balance we have. All these kind of traditional ERC20 tokens. So we're gonna do I token, private, immutable, let's call it token. That's it. Now in the constructor, we're gonna get all these kind of addresses and then initialize the objects. So we'll get address pool, address, token address. And eventually we're gonna set it up. So we'll do pool equals I pool. And don't forget to set the attacker. So attacker equals message.sender. Now we want to implement the attack function that will trigger all this kind of functionality that we described before. So we'll do function. It will get nothing. We got all the data in the constructor. It will be external. And let's see what we want to do. First, we want to borrow all the tokens, but first we need to check how much tokens the pool has. Even though we know that it has $1.5 million, 1.5 million DVD tokens, we want to make sure that we borrow all of it. So we will call a token.balanceOff. Let's do it uint balance. So now that we know the balance, we can call the borrow, the flash loan. So we'll do pool.flashloan, and the amount will be the balance. Cool. Now it will trigger the borrowing function here in the flash loan, and it will call our back to the smart contract, the selfie attacker, the receive token. So we have to implement this kind of function. So let's implement it. Function receive tokens. It will be external, and the address will be the token address, and this will be the amount. Now that we receive the token, we want to take a snapshot, so we'll do token.snapshot, and we want to add the transaction to the queue, to the governance. So before creating the transaction, we need to see how we can create it, how we can add it to the queue. So we can see that the queue action gets three parameters: receiver, which is the smart contract that is gonna trigger the function on, and then the data will represent the bytes that will represent the function and all the parameters. So we need to encode it to ABI bytecode in order to send the data, and of course the amount that we want to send to the receiver if we want to send. Then in the execution, you can see that simply it calls the function call with value, this kind of low-level function, and it sends the data and the amount, the receiver. So it's called the receiver dot function call with value. So basically, this is the smart contract that will be executed. This function will be on this smart contract, and this is data that represents the function and the parameters, the values that we're gonna send through the function. So now that we know that, we're gonna add the transaction to the queue. So we're just gonna copy paste here the queue action, and we do pull.queue action, and now we're gonna set the parameters. So the amount is gonna be 0, okay? This is the contract that we want to trigger something, a transaction. Now, what do we want to do? What do we want that this governance proposal will do? We want that it will call the function drain all funds, and the receiver is gonna be our address, the attacker, right? Because only the governance can call it. So we need to call the smart contract of the selfie pool. That's why we're gonna do address and pool. We want to call from the governance to the pool. And here we need to specify the data. So we're gonna do ABI.encode with signature. And here will be the signature string, which is gonna be this kind of function, drain all funds, and it gets address. So that's how it's gonna be. And the argument, what is the argument? The argument is the attacker. I'm sorry, it's gonna be governance.queue action, not pool, because the function queue action is on the governance. So that's basically, that's how we're gonna add the transaction to the queue that will eventually drain all the funds, will trigger the drain all funds function with the pool contract with the attacker as parameter. Quite easy, right? Now, let's get back to our plan. So once we add a transaction to the queue, now we need to pay back the loan. So that's exactly what we're gonna do. We're gonna do token, the balance, all this kind of amount. Now, eventually, after executing all this flow, the attack, the borrowing the money, adding the queue, that's all the functionality that we want to implement in the smart contract, because in order to execute a transaction, we need to wait 2 days. So we cannot execute it right after here on the same transaction, but we'll have to send a transaction later on. So that's supposed to be enough. Now it's time to deploy the smart contract, initiate the attack, and see how it works. So first thing first, we want to deploy this attacker smart contract from the factory. So we're gonna do this over here, and we'll deploy it from the attacker address. Now we want to deploy, so we'll call it deploy function. Let's do const attacker and the parameters. Of course, we have to add and await over here, and the parameters is going to be the constructor parameters, which are in the same order: pool, governance, and token address. So we'll do this .pool .address. That's it. We deploy the smart contract attacker, and now we want to call the attack function. So we're going to do await. Perfect. After executing the attack function, the flash one's supposed to work, the queue was supposed to work to the governance, and now we need to wait 2 days. Now, obviously, we're not gonna wait 2 days, so we're just gonna fast forward the EVM 2 days, which is gonna using this command, and then we can just execute the transaction. So we'll do governance dot, and we need to send it the action ID. Now, since we didn't create any other actions before, we can assume that it's 1. But in other cases, we get an event also, so we can listen to this kind of event, capture the action ID, and then we can check it out and use the action ID as hard-coded. Now we know that it's one because this is the only proposal in this kind of governance, so it's quite easy. Now everything is set up, the JavaScript code is malicious smart contract. Now let's see how we can execute the attack and how if it works. Alright, so I just added here this because there was a bug. It's this.governance, and we're gonna execute it by running yarn selfie. And eventually we can see that the exploit worked, test worked, and all the tests were passed, which means that the tokens in the pool are now on the control of the attacker, and the pool has zero balance. So this is how we can manipulate governance proposals with flash loan attacks. This is very common attack, and I hope that you guys learned something new. Let me know if you have any questions in the comments below, and if you enjoy this video, make sure to like. It really helps for the algorithm to push it to more people that want to learn smart contract hacking, and subscribe to the channel and turn on the bell notification button for more educational tutorials. Thank you so much, and I will see you in the next tutorials. Bye bye.